In this session, we will see about exclusive OR gate and exclusive NOR gate. First, we will see about exclusive OR gate. Exclusive OR gate. It is also known as XOR gate. Exclusive OR gate or XOR gate. And first, we will see the logic symbol. Logic symbol for XOR gate. So it is drawn as, I am drawing 2 input XOR gate. So this is how you draw an XOR gate, and we have one output. So this is the symbol, logic symbol of an XOR gate. We will see the truth table next. We have inputs and output. While considering input, we have 2 input A, B, and the output is Y. Different combinations of input are 0, 0, 0, 1, 1, 0, and 1, 1. So these are the different combinations of 2-bit inputs or 2 inputs. So we will see first case 0, 0, that is when A is 0 and B is 0, or we can say when both the inputs are same. In this case, both the inputs are same, that is A is 0 and B is 0. Similarly, in the last case also both inputs are same, that is A is 1 and B is 1. So for these 2 cases, the output will be 0 for an XOR gate. If all the inputs are same, then the output is 0. If all the inputs are same, then output is 0. And the output is 1 for an XOR gate if all the inputs are different. If all the inputs are different, then the output is 1. Consider the second case. A is 0 and B is 1. So both A and B are different. So the output is 1. And the third case, A is 1 and B is 0. Both A and B are different. A is 1 and B is 0. So the output is 1. So this is the truth table of XOR gate. That is, the output is 1 only if all the inputs are different. If all the inputs are same, then the output is 0. We want to find the logic expression. Logic expression. So logic expression is expressing the output Y in terms of inputs. We will see. So here the output is high in these 2 conditions. In 2 conditions the output is high for XOR gate. So we are going to write the equation from the truth table. So consider the cases where the output is high. So second case and third case the output is high. So output is high if A is 0 and B is 1, or A is 1 and B is 0. So if the value of a variable is 1, we will consider it as the variable name itself, and if the value of variable is 0, then we have to put a bar on the top of the variable. That is, if A is equal to 0, we will call it as A bar. We will learn the representation like this later. So for the time being, just know if A is equal to 0, we will usually write it as A bar in SOP form, sum of products form. And if A is equal to 1, we will write it as A itself. So here, the output is 1 in two conditions. First condition is this one, that is if A is 0 and B is 1. That is if A is 0, that is A bar, and B is 1, that is A bar dot B. B is 1, so we don't need a bar on the top of B. So output is high if A is 0 and B is 1, or one more condition is there. Or means last session we have discussed the OR gate. OR is represented by plus. Or another condition is A is 1 and B is 0. Output is also 1 if A is 0, if A is 1 and B is 0. Output is also 1 if A is 1 and B is 0. That is A and B bar. That is B is 0. That is B bar. So this is the condition. This is what we get from the truth table. So second and third condition, the output is right. That is when A is 0 and B is 1. That is what written here. That is A bar B. Or another condition is A is 1 and B is 0. That is A B bar. So this is the equation for XOR gate. A bar B plus A B bar. And for simplicity, we have a regular expression for XOR gate, for XOR operation. It is written as a circle around the plus symbol and B, and this is read as A XOR B. This is A XOR B, and it is equal to A bar B plus A B bar. A XOR B is written as in this way, and when we expand this, it is known as A bar B plus A B bar. And this is all about exclusive OR gate. Now we will see exclusive NOR gate. Exclusive NOR gate. So the name or the short form of exclusive NOR gate is XNOR. Earlier it was XOR and now it is XNOR. First we will draw the logic symbol. So the logic symbol for XNOR is the same way as we draw the XOR gate. We have drawn the XOR gate like this. Exclusive NOR gate is noting the exclusive OR gate. XNOR gate is noting the XOR gate. That means taking the opposite of XOR gate. Taking the opposite of XOR gate. So this is the XOR gate, and we have to invert it. Taking the opposite of XOR gate means first find the XOR operation and then negate it. This is the negation operator. That is the inverter operator, the round symbol, and the output way. So first find the XOR operation and invert it. This is the symbol of XNOR gate. Next we will draw the truth table. So for truth table we need inputs and outputs. Inputs and outputs. We have two input A, B and one output Y. 0, 0, 0, 1, 1, 0, 1, 1. So these are the four combinations. First case, in XOR gate, exclusive OR gate, we have seen the output is 1 only if the inputs are different, and output is 0 if all the inputs are same. Here it will be opposite because XNOR gate is the opposite of XOR gate. That means output is high if all the inputs are same, and output is 0 if the inputs are different. This is the case of XNOR gate. That is, the output is 1 or output is high if all the inputs are same, and the output is 0 if the inputs are different. The opposite case of XOR gate. So here the first condition and last condition we have output high. So we will find the logic expression. Logic expression. We have y is equal to first condition, first case. We have to consider the cases where output is high. That is the first and last case. So first case, the output is high when A is 0 and B is 0. Isn't it? Output is high when A is 0 and B is 0. That is when A is 0 and B is 0, and means multiplication and gate. That is A bar into B bar. When A is 0 and B is 0, output is high. Or other case is when A is 1, or means plus, or when A is 1 and B is 1. That is A and B. So these are the two conditions where the output of exclusive NOR gate is 1. And the symbol for exclusive NOR gate is A. We can write it as this is A XOR B, isn't it? This is A XOR B. Actually, exclusive NOR gate is the opposite of A XOR B. So we can put the whole bar. That means the opposite of XOR operation. Or we can write it as A. There is an operation for XNOR, and it is written as a circle with a dot inside, and then write B. This is also A XNOR B, and this is also A XNOR B. And when we expand A XNOR B, it is known as A bar B bar plus AB, or AB plus A bar B bar. And this is all about exclusive OR gate and exclusive NOR gate.